Welcome back, Physics 30. This is the last part of the vector section. So V1.4, adding vectors by components. So we're not going to be using the graphical method. We'll be using mathematics here. So use the trig component method to resolve a vector into its components in the x and y directions. So then use the trig component method to determine the vector resultant, VR, in problems involving vector addition or subtraction of two or more vector quantities. We'll mainly emphasize vector addition. So adding vectors graphically using a ruler and protractor is often not sufficiently accurate and is not useful in vectors in 3 dimensions. So you may have noticed comparing answers with a buddy that drawing scale diagrams you were likely off a little bit. But this being said, graphical methods are still good in visualizing problems, but they don't give the greatest answers, especially if you're comparing with other people. So components, consider first a vector v that lies in a particular plane. It can be expressed as the sum of two other pieces of vectors or components of the original vector. And then the components are usually chosen to be along two perpendicular directions, such as the x and y axis. Those are very handy to use, and that's what we'll be using. So the process of finding vector components is called resolving a vector into its components. So if we have this vector here, it's east 30 north, we can think of it as being made up of a x direction vector, which we could call Vx as you see here, and a y direction, which we call Vy. Okay, and those just happen to make a 90-degree angle. So these vector components are written as Vx and Vy respectively. So the x one lies in the x direction, the y lies in the y direction. To add the vectors using the method of components, we just need to use trig functions such as sine, cosine, and tangent, which we of course know. So of course sine is opposite side over hypotenuse. Cos is adjacent over hypotenuse, and of course tan is opposite over adjacent in that right triangle that you see there. And if we flip to the next page, we can see the components are effectively one-dimensional, so they can be added. So if I was finding this vector v here, and it's made up of v1 plus v2, of course we would draw it just like that and then go from start to finish and figure out v and then figure out the angle. But if we think of v1 as being made up of v1x and v1y, and v2 is being made up as an x movement and a y movement, take a look here. v1x plus v2x, that'd be here. Then v1y plus v2y, I'd end up at the same spot. So I could add up all the x components and then combine that with all the y components using a squared equals b squared plus c squared. I could get the answer. So adding vectors by components, draw a diagram, add the vectors graphically, choose an x and y axis, resolve each vector into x and y components. That's kind of where we're going to start. Calculate each component using sines and cosines, then add the components in each direction. Then to find the length, basically c is equal to the square root of a squared plus b squared, or all the x squared vectors plus all the y squared vectors, and then square root that. And chances are I'm going to be using tan because I'll have the opposite side and adjacent side, and then I can go from there. All right, we'll look at an example. We'll look at 2 examples actually. So we'll look at this first one. A rural mail carrier leaves the post office and drives 22 kilometers in a north direction. She then drives in the direction east 60 south for 47. What's her displacement? So the displacement really is looking at what is their resultant vector. That's really what we're being asked there. So in this case we have 2 movements. We can call it a V1 movement and a V2, vector 1 and vector 2. So vector 1, if we were just to draw it, it looks something like this. It's just simply that movement right there, 22 kilometers north. Whereas this other one is east-south, and it is 47 kilometers. Now east, the interesting thing is that it gives us our two components. Go east, then south. Go east, then south. And so it's made up of an X movement and a Y movement. So if I was figuring out all of those, if I look over here and break V1 down into an X movement and a Y movement, this is what I would have. So I would have, so in the X direction here, to go to start to finish, I didn't move anywhere horizontally, but vertically I moved 22 kilometers, and it's positive. So here we have to go back to the idea of, okay, so we have north, east, south, west, and of course east is the positive X direction in math, west is the negative X direction in math, north is positive Y, south is negative Y. So if it's pointing straight north, that's positive Y, so I leave that as a positive. And over here, okay, so east, 60, south. I know that is 60. And if I'm looking for the VX side, of course, that is the adjacent side. VY is the opposite side. So if I'm looking for my X component of my second vector, so I'll call it V2X, adjacent over hypotenuse is cosine. So cos of 20 equals Vx over my hypotenuse, which is 47. So V2x is equal to 47 multiplied by the cos of 60. Now if you're running out of room here, I actually left a lot of room on the next page to do all this. So you may want to move to there, it doesn't matter. So what I get there is V2x works out to be, let's see here, 23.500, and I usually go about 4 decimal places. Don't round off too early. And x is pointing in the east direction, so that is a positive. It doesn't hurt to put a positive there. Even though just leaving 23 is 23, we should still put the positive sign in front of it because we need directions. V2y, so of course it's the opposite sign. So I'm going to be using sine of 60 equals V2y over the hypotenuse. So in this case, V2y is equal to, so multiply each side by 47. And this time I get, let's see here, 40.7031 kilometers. Now this way, look at this, it's pointing straight down, south. That's negative y, so I'm going to have to put a negative in front of that. All right, so there, I've resolved both of these vectors down into x and y movements. So the next step is number 4, or I did number 4, calculate each component, then add each vector in its particular x and y direction. So I can continue this on the next page here. So I have x movements, so I'll just call it, now this sigma, it means the sum of, right? So the sum of all the vx's will be equal to V1x plus V2x. So my V1x, if you recall, was 0, and the V2x that I just figured out was plus 23.500. So that's going to give me plus 23.500. And adding up all the y direction vectors, so V1y and V2y, so my two y movements. So my first movement was 22 kilometers in the positive, and my second one was negative 40.7031. So that's going to give me a grand total of negative 18.7031 kilometers. Okay, so now those represent the components of the resultant vector. So I can start with either one. I'm going to start off with this one. So one movement is 23.500 in the positive x direction. So I'm not going to put a sign here because the sign tells me which direction. X direction, y direction. So I'm moving plus 23.500 And then from there, go negative 18. And of course, negative 18 is down. So don't put the negative in. The negative just tells you how to draw it. Okay, so there's my V1, my V2, or sorry, my Vx, and my Vy. Start, finish. So of course my vector is going to look like this with that angle there. So there is my resultant vector. And of course, in order to determine that, Vr is equal to the square root of 23.500 squared plus 18.7031 squared. And when you do that, I believe you get 30.03424 kilometers. And I think looking back, I think 3 sig figs is what I need for this question by looking at my original numbers. So 30.0 kilometers. And then using these values that I originally had, we have the opposite side and we have the adjacent side. So that is 10. So the opposite side is 18. See, don't put the negative down because I don't want to have negatives in this calculation. The positive and negative just tells me how to draw the components of my resultant vector. Okay, so the theta will be the inverse tan of that. So you have to figure out on your calculator, do you press inverse tan then the fraction or vice versa? Chances are it's in order as you see here. And when I do that, it works out to be 38.5 degrees. And again, make sure your calculator is in degree mode, DEG or D. So you'll have to figure that out. Because in math class, sometimes you have it changed to radians. So therefore, VR is equal to 30 kilometers, 30.0 kilometers. And as we can see, we're going east, then moving south. So east, 38.5 degrees south. Good. And of course, if you drew it the other way, if you drew south and east, that angle would be 90, subtract that. All right. There's one more question there. See if you can get a jump start. It's 3 vectors though, so see if you can do that, then tune into the next video. All right, we'll see you again.